Hi, Assalamualaikum warahmatullahi wabarakatuh, my students. Today we are going to continue chapter 10, carboxylic acid and derivatives by learning lesson 79, chemical reactions of carboxylic acid. There are reactions of carboxylic acid with reactive metals, neutralization with base, reduction with reduction reagents, formation of acyl chloride, acid anhydride, ester, and amide. As I've told you in the lecture, this goes in your mind map at the top right where there are three boxes. You have to fill in with sodium, potassium, or magnesium. This is pure metal we are using to react with carboxylic acid, and we're going to get a carboxylate salt. The second box is for a base, sodium hydroxide or potassium hydroxide. We're also going to form carboxylate salt. And the third one is for the metal carbonate, which also is going to be producing carboxylate salt together with carbon dioxide. The thing that you need to remember here is the cleavage happens between oxygen and hydrogen in the carboxyl group, and for reaction with metal we are going to produce hydrogen gas, where the observation is wooden splinter gives out a pop sound. When you do the experiment, you can put glowing splinter and then it will give you a sound, a pop sound. The hydrogen gas blows up. Okay, let's do example 10.4. As you can see here, the reactant is hexanoic acid. It reacts with sodium, one of the electropositive metals. It will form this alkanoate salt. Alkanoate salt is a raw material for us to produce alkene. Remember, there are 4 reactions to produce alkene. This is one of the raw materials or reactant. And this is the byproduct. A byproduct would be important if we have observation. So observation for this reaction is glowing splinter pops. Okay, here is your example 10.5. When you have carboxylic acid treated or neutralized with a base. The base used here is magnesium hydroxide, so you have to only replace the hydrogen atom here with a magnesium element. Alright, 10.6 is the reaction of carboxylic acid with metal carbonate, where you're going to get also an alkanoate salt or carboxylate salt. And as you can see here, we are replacing the hydrogen from the carboxyl group with the sodium from the metal carbonate. Okay, so it's going to be here COONA. This is also a raw material to produce alkene. Right, the second part of the mind map is fun reduction. Reduction is using reduction reagents. These are all 4 of them. Lithium aluminium hydrate with ether and hydronium ion, sodium boron hydrate, and then hydrogen gas with any of these 3 catalysts with heat, and finally zinc, H+ and heat. Any of these can reduce carboxylic acid to become a primary alcohol. Right, example 10.7, write the chemical equation when following carboxylic acids undergo reduction with sodium boron hydrate and give name to the products formed. I'm going to do this in the next page. This is question A, where you have a 2-methyl pentanoic acid. There are 5 carbons here. Then you want to reduce it. You are going to produce a primary alcohol at the place where the carboxyl group is. So the name would be 2-methyl pentanol. Right. For the next question, B, we have a carboxyl group here. So this part is going to become a primary alcohol. The name is 2-cyclopentyl 2-methyl propanol. Now this box is scattered all around the right and the left in the mind map. So you need to be able to find it. I think the first one, production of acyl chloride, is divided into 3 reagents. So we're going to do that next page. And then we're going to do acid anhydride. Production of ester is the one that you have learned in high school. And then lastly, production of amide. Another slide showing carboxylic acid derivatives. There are 5 that we are going to learn. Apart from carboxylic acid itself is acyl chloride, acid anhydride, ester, and amide. Look closely at the difference between all these compounds. Okay. These are the 3 reagents that I talked about just now, where we are going to produce acyl chloride. We need to use either PCl3, PCl5, or SOCl2, thionyl chloride. So what we're going to produce when we react carboxylic acid with any of these 3 reagents, we're going to produce acyl chloride where together with byproduct H3PO3 if we use PCl3, POCl3 and HCl if we use PCl5. The reason why I mentioned the byproducts are because the observation is important. HCl is in the form of gas. So if HCl is formed, we can see acidic white fumes formed. Okay, so if we use thionyl chloride, we're going to produce sulfur dioxide and also the HCl gas. Now, the cleavage is going to happen at the bond between carbon and OH. So the hydroxy part is going to come off ultimately, and then it is replaced by the chlorine supplied by the reagents. So we're going to form acyl chloride. Okay, we are seeing example 10.8, the question and the answer. The first one, we use PCl3, so we are going to take out the hydroxy part and replace it with a chlorine atom from PCl3, so we produce the byproduct H3PO3. The second compound is 4 butanoic acid. We're going to take out OH and we're going to replace it with Cl here. So it's important for us to mention that acidic white fumes is going to be released. Okay, the third question, we have a thionyl chloride over here as the reagent, and we have, where is the OH group? Yeah, here it is. The OH from the carboxyl group is going to be replaced by Cl, and this reaction will produce acidic white fumes. Now let's look at the general reaction of acid anhydride formation. We have 2 molecules of carboxylic acid and they're going to react with each other with the presence of heat. So OH is going to come off from one compound and H is going to come off from another compound. They are going to combine, becoming acid anhydride like this. This is an example 10.9 where you can see ethanoic anhydride is formed from two compounds or two molecules of ethanoic acid. Now, bear in mind, we also can produce ethanoic anhydride if we have acyl chloride. So both carboxylic acid and acyl chloride, when heated, they can form ethanoic anhydride or any acid anhydride depending on how many carbons they have. Okay, this is the general reaction for esterification, whereby you have carboxylic acid reacting with an alcohol under the influence of sulfuric acid diluted. So we're going to use its H plus from the acid, and this is a reversible reaction. We're going to produce an ester. Since this reaction is a reaction that you have learned in high school, you should be able to name the ester according to IUPAC nomenclature. So pay attention to the naming since it's going to come out in the final exam. Example 10.10 is regarding esterification. So one carboxylic acid is given to you here. Then we make a cleavage at OH for carboxylic acid, at H for alcohol. We combine them together and this name is methyl benzoate. Okay, and then question number 2, we have an aliphatic carboxylic acid here. So we cut off the bond here at OH, cut off the bond here for H at alcohol, and then combine them here. What is the name of this ester? Okay, this is the acyl part, and 1, 2, 3, this is the propanoate. So ethyl propanoate is the answer for this ester. I mean the name for this answer. Okay, the last part of this lesson is formation of amide, where we can actually produce primary, secondary, or tertiary amide depending on the ammonia and ammonium derivative that we have. And also, the reactant is not necessarily carboxylic acid. We can also use acyl chloride, same as acid anhydride. So we are going to have ammonia to form a primary amide where OH is going to cut off and NH2 is going to be replaced here. So we get this amide bonding or amide linkage. And then if we have primary amide, we're going to have secondary amide, whereas secondary amide is going to produce tertiary amide. All right. Okay, this is the example 10.11, whereby we're going to use one reactant only to be reacted with 3 different reagents. So the first one is we react with ammonia. So we are going to remove the chlorine, okay, and then we're going to add in NH2. So this is 2-methyl-propanamide. And then we're going to use this methanamine, whereby the R here is CH3, a methyl. So methyl is going to be carried together with the primary amine, okay, and it is going to form secondary amide. Now the name here is N N2-dimethylpropanamide. Okay, naming of amide is not compulsory for you. The third reagent would be a secondary amine. But naming for amine is necessary for us. So the name for this secondary amine is N-dimethyl N-methyl methanamine. N-methyl methanamine. All right. So we take these two R and then we attach it to the N. And then N is attached to the carboxyl group, replacing Cl. So the name here would be NN2-trimethyl propanamine. This is the table that I'm not able to explain in some of the classes. KSF1, KSF2, KSF3. Polyamide, a nylon, is a polymer that can be used as carpet and our clothing. And then ester is artificial flavors. Banana flavors can be artificial produced, synthetically produced. But we have the banana in our country, so no need to use the ones that is produced in the lab. Acetic acid is the vinegar in our kitchen. Ethanoic anhydride is used as aspirin, and salicylic acid is analgesic used in hospitals. So these are some of the use of carboxylic acid. There are more. Okay, thank you very much for watching, and I'll see you again in the next lesson. Assalamualaikum warahmatullahi wabarakatuh. Salam Eidul Fitri, everybody.